Leia here from leiaforsci.com, and in this video I'm going to show you how to solve Orgo 2 Final Exam Question 6. You can download the exam and solutions on my website, leiaforsci.com/Orgo2Final. For question 6, we're told to show how to synthesize the molecule below, starting from toluene and any inorganic reagents, meaning the only source of carbon is toluene and nothing else, and we have a hint to count the carbons. Whenever you're working through synthesis, you want to ask yourself two questions. What stayed the same and what changed? Knowing that we have to start with toluene, we have to figure out where toluene is in this molecule. First, we have to know what is toluene. Toluene is a benzene ring with a single carbon substituent. So we're looking for 7 carbon fragments that will be our starting molecules. Here we have one toluene, a second toluene, and a third toluene. So this molecule started out so overwhelming, turns out to be nothing more than 3 toluenes fused, and the only additional atoms are an OH group. Great, so we know where it came from, we know what changed, but how do we work out this reaction? Here's where you need to keep in mind the following trick. If you're asked to synthesize a tertiary alcohol, and you notice that you have 2 of the same substituents, then you want to start out with an acyl group attacked by 2 Grignards. So we need to figure out which was the acyl group and which was the Grignard. Given that this carbon here is the one that's holding the oxygen, and the acyl group has oxygen, that had to come from the acyl portion of the molecule. This toluene has to be turned into an acyl group, and the 2 identical substituents that are attached had to come from a Grignard. So we want to turn these 2 toluenes into Grignards. We know what we have to do. Let's do this retrosynthesis or backward style to figure out how we came up with this monstrosity starting from just toluene. Anytime you have a Grignard attack, the pre-final product will be a negative oxygen. So let's backtrack one step and show that we have the toluene from the acyl group with an O- attached to it. The new bonds where the 2 Grignards attacked will show in red, and the toluenes from Grignards in a different color to know where they came from. It looks a little different, but it's the same thing. Grignards will attack twice when reacted with an ester or an acid halide. The problem is that an ester has the formula ROOR', and that R is additional carbon groups that we don't have for our reaction. So instead, we want to use the acid halide. So we'll backtrack one step and show our acyl halide, which in this case is an acyl chloride, and we're reacting it with 2 equivalents of a Grignard made from toluene. We'll show how to make the Grignard in a moment. First, let's see how we get that acid halide. You should recognize this as a carboxylic acid derivative reaction where your carboxylic acid is turned into an acid halide. So let's backtrack this to a carboxylic acid. And the carboxylic acid is very easy to make from toluene with one simple, strong oxidation reaction. And here's our starting molecule. Now let's work forward and fill in our reagents. KMnO4 will have a very strong reaction with a benzylic carbon, meaning a carbon directly attached to a benzene ring. It'll oxidize it all the way to a carboxylic acid. KMnO4 and heat to help drive that reaction. Once we have a carboxylic acid, we turn it into an acid halide by using SOCl2 in a pyridine solution. The Grignard will show how to make separately, so we know that we're reacting with the Grignard, and in the final step we want to react it with acid to protonate that negative oxygen, giving us our final product. Now let's show how to create the Grignard from toluene. And you can show this one forwards or backwards because this is a reaction that you should know quite well. Remember that we're carrying out this reaction twice or with 2 equivalents to make sure we have enough Grignard to attack the acid halide. The first thing we have to do is introduce reactivity onto the molecule because toluene has just carbons and is not very reactive. To do that, we'll do a radical halogenation, giving us a bromine on the benzylic position. Once we have a bromine, it's very easy to turn that into a Grignard, and that's our final product. How do we carry out this transformation? For the radical addition of bromine at a benzylic position, we want to use NBS. NBS is ideal for introducing bromine under radical conditions to allylic and benzylic carbons. In this case, we have the benzylic. Once we have a halogen on the molecule, we react it with magnesium dissolved in an ether solution, for example THF or diethyl ether. That'll give us the Grignard. Then we take that Grignard, react it with our acid halide, and that gives us our final product. If you're trying to save space on your exam, you can just fill it in like this. The Grignard comes from having a bromine, and that reaction was carried out in magnesium with something like ET2O, diethyl ether. Getting the bromine onto toluene came about by reacting NBS to get it there under radical conditions. Be sure to join me in the next video where we solve the Orgo 2 Final Exam Question 7. You can download this exam and solutions on my website at layerforsci.com/orgo2final.